In this lesson, we're going to do some more work on product rule for counting from the Further Maths GCSE syllabus, and we will be extending the techniques that we learnt last lesson. Let's have a look at the first example. So, Tom's going to make a 4-digit number from the following cards. So because he's only got the following cards to choose from, he can only select each number once, and he's going to make a 4-digit number. So I'm going to write 4 boxes. Now the number must be odd, which means it can have a 3, a 5 and a 7 at the end. And it must be smaller than 5,000, which means it can have a 3 or a 4 at the beginning. Now we need to be a little bit careful here, because I cannot have a 3 at the beginning and a 3 at the end, because I can only use each card once. So the simplest way to do this is to separate out either the beginning 2 numbers or the end 3 numbers. So let's do the beginning 2 numbers. So now in scenario 1, I've got a 3 at the beginning. Doesn't matter what I have in the middle, and because I've used the 3 to make it odd, I can only have the 5 and 7 at the end. In scenario 2, I can have a 4 at the beginning. Doesn't matter what I have in the middle, and I could have a 3, a 5, a 7 at the end. So there's only one way I can have a 3 at the beginning, and there are 2 ways I can have the 2 numbers at the end. If I've got chosen 1 number for the beginning and 1 for the end, that leaves me 3 numbers for this position to choose from and 2 for this position. Multiply them all together and I get 12 possible 4-digit numbers. Similarly on scenario 2, there's only one way of getting a 4 there. There's 3 ways of getting 3, 5 or 7. 1 number at the beginning and a fixed number, 1 number at the end gives me a choice of 3 for the second position and 2 digits for the third position. Multiply them together and that gives me 18. So I've got 12 plus 18, which gives me 30 possible 4-digit odd numbers less than 5,000. Okay, let's look at this slightly different example. So Carrie makes a 5-digit number, so she can choose from the digits 0 to 9. Okay, and because she's just choosing a 5-digit number, she can choose these digits more than once. Right, it's a 5-digit number, so let's put in our 5 boxes. So the number is odd, so that means at the end I can have 1, 3, 5, 7 or 9. So that's 5 different options for the last number. Let's go to this situation now. The third digit is double the second. So here's my second and third digit, and I need to consider them together. And really for this, the only way to go about it is to consider the different possibilities. So if the second digit's 1, the third digit must be 2. Second digit's 2, third digit 4. If we carry on with this, I could have 3 and 6, or 4 and 8. So that's 4 different possible combinations for the second and third digit. So for the fourth digit here, I can have any of my digits 0 to 9, so there's 10 possibilities. Now we need to be a little bit careful here with the first digit because it has to be a 5-digit number, so this cannot be 0. Okay, cannot be 0 here because if it was, it wouldn't be a 5-digit number, so I can only choose the digits 1 to 9 there, so I've only got 9 possibilities. So those are my numbers to multiply together, and that gives me 1,800 different numbers that Carrie can make. Right, we're just going to have a look at a couple of slightly different examples. That was a loud motorbike just went past, never mind. Right, so here we want how many numbers less than 4,000 can be made using each of the above digits no more than once. So it's got to be less than 4,000. So let's start with 4,000. So we can have a 4-digit number. So let's start with 4 boxes. If I've got a 4-digit number to be less than 4,000, I could have a 3 here or a 1 here. That gives me 2 options. Once I've fixed one number here, because I've got 6 digits to choose from, I've got 5 for that position, 4 for that position, and 3 for that position. So that gives me 120 4-digit numbers. But just because it's just less than 4,000, I could have 3-digit numbers that I also need to consider. So if I look at the 3-digit numbers, I can have any of my 6 digits in first position. That leaves me 5 for the second and 4 for the third. So that's again 120 3-digit numbers. I'm also going to need to consider the 2-digit numbers. Again, I could have any of the 6 in the first position and 5 in the second position, so that's going to give me 32-digit numbers, and I could also have a 1-digit number. Okay, I've got 6 possibilities for a 1-digit number. If we add all of these up, we get 276 numbers less than 4,000 that can be made. So just be a little bit careful. Quite often you have a number with a fixed number of digits, but if it's less than 4,000, I have to consider numbers of digits below 4 digits as well. Right, one more to look at, just to give you a taste of something that could come up that's a little bit more challenging and requires some thought. Okay, so this is looking at vehicle registration plates. So here's an example of one down here. So if we just have a look at it, the first 2 letters in the vehicle registration plate can be any 2 letters, but they don't use an I, a Q or a Z, and that identifies where the vehicle was registered. So if we could have any letters excluding I, Q or Z, that leaves me with 23 letters to choose from. Okay. There follows 2 digits which identify the age of the vehicle, so we can have any digits in here apart from 0, 1. So we could have 0, 0. We can't have 0, 1, but we could then have 0, 2 to 99. So that's going to give me 99 2-digit numbers to choose from. So again here you'll see I'm considering those together as a group. Finally, there are 3 more letters that I can choose from, but I exclude an I or a Q. So that gives me 24 letters to choose from here. So if I draw my boxes, my first 2 letters, then 2 numbers, and then 3 letters. So I've got 23 letters I can pick for the first letter and 23 for the second, because I can have repeats of letters. The digits I'm considering together, and there are 99 possible 2-digit numbers excluding 01, and for the last 3 letters I've got 24 to choose from for each of them. So if we multiply all of those together, we get a very large number, 723,976,704 possible different registration plates. So what I want you to do now is have lots and lots and lots of practice of these. So let's have a look at what we're going to do. I want you to go to the Corbett Maths Level 2 Further Maths Product Rule for Counting questions. We're going to do all of these questions, but quite importantly start on question 2 and go back to question 1 at the end. And then when you've finished those, I want you to go to the AQA Further Maths textbook, back to that exercise 1I, and complete the exercise question 7 to 13.